Good day, everyone. My name is Simone Okes, and I'm present in the International Conference on Digital Technology Driven Engineering 2025, which took place in Jordan, December 18th to 20th, 2025. I'll be doing a presentation on integrating machine learning and GIS technique for optimal setting of utility scale solar photovoltaic systems in Morocco. In the whole of the United Kingdom, United States of America, and US at large, these areas prioritize net zero energy, which helps to bring about an eco-friendly environment. Therefore, global solar photovoltaic system deployment has increased rapidly due to its cost, the reduction in its cost, and the strong policy which supports this system. Poor setting can lead to land use conflicts and also have negative impact on the economy. GIS and multi-criteria decision analysis, especially analytical hierarchy processing, is widely used for renewable energy setting. Therefore, this study proposes a hybrid GIS analytical hierarchy processing machine learning framework, which will help to improve transparency and predictive accuracy. The statement of the problem: traditional analytical hierarchy processing relies on the knowledge of experts, which may be biased because they may not generalize across all regions. They may just be knowledgeable in certain areas or in areas they are familiar with. Many studies usually lack validation with measured or modeled photovoltaic output. Exclusionary zones, which include protected areas, steep slope, as well as urban core, can be simplified or omitted due to the knowledge of these experts which we rely on. And also, there's a need for data-driven, validated, and reproducible solar setting workflow. As mentioned earlier, Maricopa County was where this study was carried out, and it is located in south central Arizona. As you can see on the map, it is a hot, arid region. For data and criteria, we have solar criterization as well as the data source, the purpose of the study, and resolution. We have solar irradiance, we have global horizontal irradiance, then we also have photovoltaic output, slope and elevation. We have the data source shown there, the purpose and the resolution. We have land use, land cover. We also have distance transmission, and we have distance to road, as well as these protected areas. Protected areas include steep slope and urban slope. For the methodology, seven special criteria was used, which include global horizontal irradiance with slope elevation and land use land cover, road grid, and exclusion zones. These exclusion zones could be steep slope, urban slope as well. Analytical hierarchy processing for experts with random forest, and extreme gradient boosting for machine learning weight. Also, weighted linear combination, which was used for final suitability. For the machine learning model, three models were used. The first model used was the random forest model, the extreme gradient boost model, and linear regression. Out of all these machine learning models, random forest model and extreme gradient boost was the two most suitable models for the study because both models were closest to one, whereas the linear regression model was only suitable for global horizontal irradiance only. This is a map showing exclusionary zones and non-exclusionary zones. The first one shows exclusionary zones, and the figure two shows first figure shows non-exclusionary zones, and the second figure shows exclusionary zone. Here we have for the unsuitable. For energy potential, we have about 25 terawatt hours annual technical potential. The treatable areas are about 4,949.94 kilometers square, and this could supply about 2.3 million households. Conclusively, hybrid GIS analytical hierarchy processing machine learning model brings about a relationship between expert judgment and empirical evidence. And empirical evidence refers to evidence that are seen or can be observed. Also, high priority corridors, which aligns with infrastructure and minimizes land use conflicts and grid connection costs. In other words, when the most suitable areas are found, this will help to reduce a lot of negative factors as it will help to minimize cost. Framework could be transferable to other arid and semi-arid regions and can be extended with economic and ecological layer. In other words, if this framework could be used in Maricopa County, it could also be used in other parts of the United States of America as well as Europe as a whole and in every other continent that will want to be a part of the solar photovoltaic system. These are a list of references and thank you.